Hi class, in this lesson you will learn to use both the perpendicular and angle bisectors to solve problems. So let's go ahead and get started. First we have the perpendicular bisector theorem, and what this theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, so what this is basically saying is here we have line L and it bisects segment XY and it bisects it at a perpendicular angle. Okay, so when you have that scenario, any point on this line will be equidistant to the end points of the segment. So PX will be equal to PY. Okay, so if P were down here, then this distance from P to X will also be the same as P to Y. So any point on this line, on this perpendicular bisector, which I have in green, any point on that line, that the distance from that point, wherever it is on the line, to the ends of this blue segment will be equal. Okay, so that's the perpendicular bisector theorem. Now the converse is also true. Okay, the converse of the perpendicular bisector theorem states that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Okay, so in other words, let's say we have point Q, okay, and the point Q is equidistant, meaning the distance from Q to X, this distance here, is the same as this distance here, Q to Y. So if they are equal, then the converse of the perpendicular bisector theorem says that this point is on the perpendicular bisector. Okay, so XQ, which is this distance here, is equal to YQ, which is this distance here, and line PQ, which is this green line, is perpendicular, okay, to the segment XY. Okay, so given both of those bisector theorems, let's go ahead and apply them to the next couple of examples. So here is example 1, and the question is, what is the value of AD? So we want to know what this value is. What is this length, okay, or what is this distance? Okay, so here's what we know. We have a perpendicular line, and it bisects, cuts BD exactly in half. And how do we know that? We are told that the length of BC is 11, and the length of CD is also 11. So we know that this is a perpendicular bisector. Okay, now, according to the theorem, any point on this line, okay, and in this case we have point A, the distance from point A to B will be identical to the distance from point A to D. So in other words, AB is equal to AD. Okay, so segment AB is equal to segment AD. Okay, as I've always said in class, before you solve these types of problems, always establish the relationship first. Okay, so that's what we've done here. AB is equal to AD. AB is equal to AD. Now that we know that the relationship is established, we can go ahead and replace AB with the expression given. So this is 6x minus 10, and that's going to be equal to 3x plus 2, which is my AD. Okay, 3x plus 2. Okay, so now we have an algebraic equation, and we can go ahead and solve for x. So if we subtract 3x from both sides, okay, we get 3x on this side minus 10, and these cancel out, and we're left with 2. And then the next step is to add 2 to both sides. I'm sorry, 10 to both sides. Okay, and we do that so that we can eliminate this, and we're left with 3x is equal to 12. And the last step is to divide both sides by 3 because we want to isolate x. and we see that x is equal to 4. Okay, that is not the end of the problem. Remember, we want to know the value of AD. Okay, this is AD. Well, what is AD? AD is equal to this expression given to us, 3x plus 2. Okay, and we know we just solved that x is equal to 4, so we're going to substitute that in for x. So then this becomes 3 times 4 plus 2. This works out to 12 plus 2. And so AD, the value of AD is 14. Okay? All right, so let's go ahead and move on to example 2. Here in example 2, we need to figure out the value of WY. Okay, the value of WY. Okay, so in the converse of the bisector theorem, okay, we are told that if the distance from a point to the ends of the segment, so from Z to X, if this distance is equal to this distance, ZY, then this point must be on the perpendicular bisector. Okay, here's the perpendicular bisector, and bisector means it cuts this segment here, XY, exactly in half, which means that XW is equal to WY. Okay, so using the theorem, what we've concluded is that XW is equal to WY. Okay, we've established that relationship. We know that to be true based on the theorem, and so now we can go ahead and substitute XW with the expression given, which is 5n minus 2. And then for WY is 2n plus 7. So we can go ahead and substitute that. And now we can solve for n. Okay, so first we're going to subtract 2n from both sides. And when we do, we eliminate that, and we're left with 3n minus 2 is equal to 7. Now we want to move this negative 2 to the other side of the equation, and we do that by adding 2 to both sides. And when we do, these cancel out, and we're left with 3n is equal to 9. And then we want to isolate n by dividing 3 on both sides. And now we're left with n is equal to 3. Okay? Now again, we are not finished with this problem because we want to find the value of WY. Well, what is WY? WY is equal to 2n plus 7. And we solved for n, which is 3. So we're going to substitute this n with the value that we just solved. So then this becomes 2 times 3 plus 7. And this works out to 6 plus 7. And what we find is that WY is equal to 13. Okay, let's move on to example 3. Okay, here's a more complicated example, and we're going to see how both the theorem, the bisector theorem, and the converse helps us solve this particular problem. Okay, so first let's take a look at this larger triangle. Okay, triangle KJL. Okay, KJL. What we see is that segment JK is 17 and segment KL is also 17. And because these are equidistant, we know it's on a perpendicular bisector. Okay, this point is on the perpendicular bisector. And what does the perpendicular bisector tell us? KN cuts the segment JL exactly in half. So because we know that JN, this segment here, is 14, then we must know, therefore, that NL is also 14. Okay, so from here, I'm going to make a notation here. This is also 14. Okay, so now that we've established the length of this segment, we can now focus on this smaller triangle, because ultimately we want to know the value of OL. Okay, so what do we have here? We know that MN, segment MN, is 9, and it is the same length as segment ML, which is also 9. Okay, so this tells me that this point is on a perpendicular bisector. Okay, and since this is a perpendicular bisector, we know that this MO, this perpendicular line, cuts NL exactly in half. Okay, well, we know NL, we just solved, is 14, and so half of 14 is therefore 7. Okay, and so our answer is OL is equal to 7. Okay, all right, so let's move on to the next theorem. This is the angle bisector theorem, and it states that if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. Okay, so what is this saying? So basically, we have this line AD, okay, and this is in a bisector of angle BAC. So in other words, AD cuts this angle exactly in half, and here's the notation, right? This angle is equal to that angle, so that's a bisector. And what this theorem is saying is that if a point is on this bisector, then this distance from D to B will be exactly the same as the distance D to C. Hence, BD, segment BD is equal to CD, okay? This segment BD is going to be equal to CD. Okay, and then the converse is also true. Here's the converse of the angle bisector theorem, and it states that if a point is equidistant from two sides of an angle, then it is on the angle bisector. Okay, so in other words, we have point D, and if BD, if this segment is equal to segment CD, then we know that this point is on a bisector, angle bisector. So then we would know that angle, okay, BAD, so this BAD, so this angle here is going to be equal to angle CAD, so this angle here. All right, so we know that this angle here will be the same as that angle. Okay, so let's go ahead and use both of these theorems to solve the next couple of problems. So here's example 4. The question is, what is the value of KL? Okay, what is the value of this segment KL? Okay, so what do we know? We know that JL is an angle bisector. And how do we know that? We see these markings here. They tell us that those angles are the same, which means this bisector cuts angle KJM exactly in half. Okay, now according to the angle bisector theorem, if a point is on the bisector, so point L is on the angle bisector, then the distance from L to K is going to be the same as the distance from L to M. Okay, so let's go ahead and establish that relationship. So we know that segment, let's just call it KL. Doesn't matter if it's called LK or KL. We'll call this KL. Segment KL is equal to the segment LM. Okay, so that is the relationship that we are establishing. Okay, now that we know that that's true, we can go ahead and substitute KL with this expression, 2x plus 3. So 2x plus 3 is going to equal LM. Okay, this is LM, and here is the expression for LM, 4x minus 11. Now we have an algebraic equation. We can go ahead and solve for x. Okay, so some of you may be asking at this point, how do you know which way to move, what to move? What exactly do you move? All right, so the way I would explain this is we have a 2x here and we have a 4x here, okay? We want to move one of those so that I end up having a positive x. Well, if I move 2x over to this side of the equation, then when I subtract it, it's going to be a positive number. Okay, I don't want to move 4x over to this side, because if I move this over to that side, then I'm going to get 2x minus 4x, which will give me a negative 2x. And I want to stay away from a negative number. It's not to say that you can't do that. It still will be correct, but it just complicates things a little bit. Okay. All right. So let's go ahead and subtract 2x from both sides. And when we do, these cancel out, and we're left with 3 is equal to 2x minus 11. Okay. Now we're going to take this negative 11 and move it to the other side, and we do that by adding 11 to both sides of the equation. And when we do, we get 14 is equal to 2x, and these cancel out. Okay. Now the last step is to isolate x, and we do that by dividing 2 from both sides. And when we do, we get x is equal to 7. Okay. Now again, we're not done here. We've just solved for the value of x. Remember that we are looking for the value of KL. Well, what is KL? KL is equal to this expression 2x plus 3. Okay, 2x plus 3. Now we can substitute this x with what we just solved here, which is 7. Okay, so then this becomes 2 times 7 plus 3, and this results in 14 plus 3. And then our answer for segment KL is going to be 7t. Okay? All right, let's go on to our last example. And this example has 2 parts. Okay? So let's take a look at this figure here. In part A, it says that if HI is 7, okay, so if this segment is 7 and IJ is also 7, IJ is also 7, okay? So right off the bat, we know that both of these are equal. And according to the theorem, the angle bisector theorem, or the converse of the angle bisector theorem, we know that if these are equal, then we know that this point is on an angle bisector, okay? So now we know this is an angle bisector, meaning this cuts angle HGJ exactly in half. Now, what we're told also is that angle HGI, okay, HGI is 25. All right, so let's go ahead and label that. HGI is 25. This is 25 degrees, okay? So the question is, what is angle IGJ? Well, we just figured out that this is an angle bisector. It cuts this angle exactly in half. And so if this angle, HGI, is 25, then IGJ is also 25. Okay? So then this is going to be equal to 25. So that's the answer for part A. And then for part B, we are told that the measure of angle HGJ is 57. Okay? So let's go ahead and delete this, erase this. All right, so for part B, we are told that HGJ is 57, okay? So this entire angle is 57. And we're also told that IGJ is 28.5. 28.5 is exactly half of 57, okay? So what this is telling me is that both of these angles are the same. They are 28.5. And what does the angle bisector tell us? Well, we know that this is an angle bisector because we just figured out that both of these angles are the same. So let's go ahead and label that. This is 28.5 degrees and this is 28.5 degrees, okay? Because both of those angles are the same, we know this is a bisector, and the angle bisector tells us that a point on the angle bisector tells us that the distance from I to H is equal to I to J. Okay, so we know that both of these segments are going to be equal. Now this problem tells us that HI is equal to 12.2. This is 12.2. And the question is, what is the value of IJ? Well, if this is 12.2, then IJ must be 12.2 also. So the answer here is 12.2. 2. Okay? All right, hopefully that made sense. If any of this was confusing, please go back to the beginning of this recording and listen to it again. Thank you.